Hi everyone. This is our first lecture for structures, and we will be looking into the basics of it because this is the base for all the questions that come in game. Like, if you know the basics, like if you know what are the different supports and reactions, you will be able to solve all the SFT BMD problems, all the trust problems, and everything else in the syllabus. So, I hope you go through this particular syllabus well, and if you have any doubts, do let me know in the comment section. So, yeah, let's just start. So, starting off with the different supports that are there in a structure that we are going to look particularly for GATE exam. First one is our fixed support. Okay, this is our fixed support. Then comes hinge or pin support, which means this. And then comes our roller support. So, roller support can be annotated in two types. One is this or this. So in standard books, you can see this to be used, and that's what I also follow. So moving forward, we'll be using this particular annotation for roller support, and I hope you can carry it forward too. So yeah, these are the three supports that we are going to look into. And then the support reactions are also being covered with respect to this particular support. Okay, so yeah, next is our types of reactions or the support reactions, as in the reactions which act with respect to these different types of supports. So in hinge support, we have three different types of reactions. One is a vertical reaction, so we would call it RY because it's in the Y axis, right? Then one horizontal reaction and a rotation, a moment is created. So let's call it RZ. So a total of three reactions in a fixed support. All right. In a hinge support, we have a vertical reaction and a horizontal reaction. So in total, we have two reactions in a hinge support. And for a roller support, I'll erase that annotation for now. Yeah. For a roller support, we have only a vertical reaction. All right. So do remember these three things because it's like a thumb rule and you'll be able to solve your numericals for SFD and BMD and all the other topics with your base being built on these three supports. Okay. So let's say you have a beam here. Okay. And it has hinge support, two hinge supports, and one roller support. How many reactions would it form? Ry, Rz, Rx. So this would have Ry, 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 and here we have Rz. Here again we have another Rz, right? So we have Z is 0. Sorry, this is Rx. Z is for the 3D, as in the rotation. We have Ry 3, Rx 2. So these are the reactions that were there in this particular system. Okay, so we understood what are the different types of systems, the different reactions that occur. Now let's understand what are the different beam types. Okay, these are all very short concepts that form the basis of your structures. Okay, okay, let's understand different types of beams. First type would be a simple supported beam. where wherein you have one roller and one hinge. Okay. Then you have a cantilever beam where you have a fixed support and the beam is here. Okay. This is like this. This is your beam. Okay. And the third one is a fixed support, which means it would have support on both the ends. So now hurry up and tell me how many reactions would each of these beam types would have. You can pause the video, write down your answers, and then check whether it's matching with mine. Okay? So starting with the simply supported, here we have a hinge support, which means this, right? Ry, Rx. This one's a roller support, which means Ry. All right? So here we have three reactions. Then in a cantilever, how many reactions would we have? Cantilever has one fixed, right? So it means Ry, Rx, and a rotation, Rz. So three reactions. Fixed support. Fixed support means it has both sides. Okay. So Ry, Rx, Rz. Again, Ry. Let's call it 1, 2, 1, 1. So this would be Rx2, Rz2. So in total, it will have six reactions. Clear? So we know what are the different types of beams. Okay. So I taught you the basic, like the basics of beams, right? The three types of beams. Now there would be many other beams which would be a combination of all the three. So you can find beams which are a simple supporting beam, for example. Okay. We have this, and an overhang here. Or we can have a fixed beam like this one, and then we might have a hinge, and then again an overhang. So these are all a combination of all the three that I have taught you. So if these come, I hope you'll be able to find out the reactions because you know the basics now. Okay? Okay. So we are done with types of beams. Now, rigid body equilibrium. What does this mean? So let's just take an example. Uh, Suppose we have this particular beam. It's a simple supported beam, and we have a point load. Okay. Again, there are different types of loads that we are going to learn about. One can be a point load, which is acting at a certain point. One would be a uniformly distributed load, which has equal load at each interval. One would be varying load. Okay. So all of this we are going to focus on later. But for now, just understand that this point load is what we are looking at right now. Okay. So this is a point load, let's say, and it has a magnitude of 10 kilonewtons, let's assume. So point load is a force, right? And force is measured in newtons or kilonewtons and equivalent units. So that's what I wrote, 10 kilonewtons. Okay. And let's write the other units as well. Suppose this is a beam and probably this is at 2 meters from one end and this is at 4 meters and one end. This is 6 meters. All right. Now, let's also write down the reactions that occur. So this is a hinge support, so we know what would be the reaction. Ry, Rz. Okay. This is going to be Ry again, but let's say this is Ry1, this is Ry2. Okay. So what does this rigid body equilibrium mean? It means that the sum of all the forces acting on a beam or a body are going to be equal. As in, if all the forces that are acting from upward to downward are going to be equal to all the forces, summation of all the forces that are acting from downward to upward, which means 10 kilonewton. Okay, we have only one force, 10 kilonewton acting from upward to downward, will be equal to all the forces, vertical forces. Okay, similar types of forces. So from downward to upward, we only have ry1 plus ry2. So this is our equation. Similarly, this equals this. So Rz equal to, is there any other horizontal reaction that we are finding here? No, right? So it's zero. There's none. So the value of Rz is zero. Similarly, we talked about the vertical reaction, we talked about the horizontal reaction. Now let's talk about the moment. So what is a moment? Okay, a rotational force. So how do you calculate the magnitude of that rotational force? You call it a moment, which is nothing but force into distance. All right, force into distance. Now, this is the force that's acting, right? This, what is the distance? So if you're trying to calculate the moment at this particular point, or let's say you want to calculate the moment from here to here, whatever the moment is being created would be equal to the moment from here to here. All right. So how do we calculate that? If I want to calculate the moment at this particular point, okay, then what I'll do is I'll calculate this force and the distance up till this point because I want to calculate the moment up till here. All right. So what is the force? I have this force. And what is the distance? It's 2. Let's see what it comes out to be. Basically, moment when you calculate from here to here and from here to here should be equal. All right. So Ry into 2 meters. So Ry would have been in kilonewton and this is in meters. So our moment unit is kilonewton meter or Newton meters. So it would be equal to Ry2 into 4 meters. Why 4 meters? Because the distance from this point to this point is 4 meters. So we have to be very careful of what uh, numerical value we are taking. Okay. So this would be equal to this, which means that the moment at this point is equal even if we calculate from here or we calculate from here. All right. Now the uh, moment, when we calculate moment, it can be positive and it can be negative. Okay. When a moment is negative and when a moment is positive, let's see that. Taking the same example here again. So if I see from this particular line, call it C. This force, this force is going to bend the beam this way. If I try to look in this direction, all right, looking into this direction, my force is going to bend in this way, the beam, all right. So if it's bending the beam in this way, if I look here, so it's creating a clockwise direction, right? So whenever a force is trying to bend the beam in a clockwise direction, the moment created is a positive moment, as in the sign of that moment would be positive. Similarly, now if I look at the same point load in this direction, and how is this load affecting this side of the beam? Let's see that. This is going to bend the beam in this direction, won't it? Like this is going to be like this somehow, somewhere like this. So it's going to create a moment in this direction, right? And this is what?
a negative anti-clockwise direction. Hence, somewhere just write it down that moment created in this direction is positive, whereas moment created in this direction is negative. All right, I'll highlight myself. Along with point load, since we're talking about signages, so while you are trying to calculate and while you're trying to solve the equations, signages play a very important role. All right. So you're clear with the moment signage. Let's talk about vertical reaction ka signage. Okay. So this is a positive sign. Just remember for now. I'll tell you how is this going to be used later on. Okay. And this is a negative sign. All right. So yeah, these are the basics. Let's try to solve a few questions where I would just check whether you know what would be the reactions. If a missing reaction is there in a particular system, beam system, okay, you'll be able to use all this basics that I taught. So I want to move step by step. So for now, we'll just solve that particular question, which tries to test whether you understood the reaction ka funda. Okay. First question, a very basic question. Suppose this is my fixed beam and it also has a roller support, okay? And it also has a reaction R of suppose 2 kilonewton. Fine. It has a point load 4 kilonewton. What would be the reaction, vertical reaction at this point? Let's say this is A, this is B, this is C. What would be the reaction? RA. RA का reaction क्या होगा? You can pause the video, try it on your own. So as I said, this equals this. So 4 kilonewton equals, we have 2 kilonewton plus RA. So RA is nothing but 2 kilonewtons. All right. And if you're confused, कि यहाँ पे I said it's positive and यहाँ पे I said it's negative. Why? Because when I talk about equilibrium, right? So this plus this should be zero, right? अगर मैं बोल रही हूँ कि ये positive है और ये negative है, so this is obviously going to be zero. So I can say this equals this, right? So this is just general arithmetic, right? So instead of writing this plus this equals to zero, I wrote this. Okay? So you understood this? Let's do another question. Support and support. Let's say this is 10 kilonewton, this is P kilonewton, this is 1 kilonewton, this is also 1 kilonewton, and this is 2 kilonewton. You have to find out this. Try to calculate, pause the video, try to solve it on your own. If you have an answer and you're not confident, let's see, you'll at least learn something. So again, this equals this, right? So how many downward forces? I have 10 kilonewtons and I have P kilonewtons. Equals upward forces, we have 1 plus 2 kilonewtons. So 10 kilonewton plus P equals 2, 3, 4, 4 kilonewtons. So P is going to be 4 minus of 10 kilonewtons, which means minus of 6 kilonewtons. Okay, so how many of you got minus 6 kilonewtons? Do you think it's correct or it's wrong? Or do you have a justification? Because if you do, you have understood the concept very well, and kudos to that. So minus 6 is not the wrong answer, it's the correct answer. How is this going to change the question? See, I told you, right? अगर ऊपर से नीचे force is coming, it's a positive force. If it's going in this direction, it's a negative force. So I got a negative sign. So this means that P, though in the questions given an upward force, magnitude was not known. In actual, it's going like this. Okay? And its magnitude is this. So understand that minus is not the magnitude. A force can never be negative. All right. It only shows you the direction of force. Okay? So the direction is going from downwards to upwards. It's in this direction and this not. So your revised drawing would be like this, where P is equals to 6 kilonewtons. So I hope you learned something new today. I hope your basics are clear because next class we would be solving SFD and BMD and we'll start with basics again. We'll start with level 1 questions and then move ahead to the difficulty levels. And we'll also solve a few gate questions. So I'd like to say that in gate, for structure specifically, they do not bring in new or innovative questions. Most of it are repetitive concept-based questions. So if you have your concepts clear, you'll ace it. All right. So hope to see you in the next class. Bye bye.